Hey, this is Miss Doherty. I'm doing the demonstration of Charles's Law. So I've got some drawings here on the board. I'll stand aside and let you see. We're going to fill these in. But I've got a balloon that I've blown up, and this balloon is at a certain temperature. It's at room temperature because I blew it up with molecules from the air, and I know it's about 23 degrees in here. So our initial temperature, or we're going to call it T1, is 23 degrees. And I'm going to take the circumference, and you can put circumference into a formula to determine volume, but we're not going to do that today. We're just going to worry about circumference. So the circumference of the balloon is 28.4 centimeters. Okay, so at room temperature, our balloon has a circumference of 28.4 centimeters. And what's going on inside the balloon? You know that there's molecules of air. You can't see them, can't directly observe them, but you know they're there. And they're creating the shape of the balloon because they're moving around and they're pushing on, applying a force to the walls of the balloon. And that's called air pressure. When air pushes against the walls of something, it's called air pressure. Okay, so I'm going to get the balloon wet to lubricate it a little bit. I'm going to put it in this boiling water. So you need to watch what happens. Okay, if you hear a funny noise, they're running the waxer out in the hall. So you can see that the balloon is lifting up out of the beaker. And we're going to measure it in a minute. It appears to be getting bigger. So what I've drawn over here is a piston, like in the engine of your car. And that's what's happening in here. The boiling water has a lot of energy. It's hitting the bottom of this balloon just like gasoline would hit the bottom of your piston. It's causing the balloon to rise up, just like what happened in your car. That's another thing I just wanted you to recognize that that's what's happening in here, because we will be talking more about pistons and plungers and things later. Okay, this is the exciting part, waiting for something to happen. I think somebody's trying to come in. Still rising. Okay, I'm going to go ahead and shut it off now and take the new circumference is 33.0. Put it back here so it can stay big. So our new circumference is 33.0 centimeters. So here's what happened. As we increase the temperature of the air around the balloon, the temperature of the air in the balloon increased, so it gained kinetic energy. The particles in the balloon start moving faster, and they hit the walls of the balloon harder, which increases the air pressure, causes the balloon to get bigger. So you see, when the temperature is low here at 23 degrees, our volume, or our circumference was low. You can calculate volume from circumference, so I'm going to call it volume. Our volume was low. We increased the temperature, and the volume also increased. Okay, now I'm going to take this 33 centimeter balloon, and I'm going to put it into cold water. Now, I don't know what the air inside the balloon, it's getting really big, isn't it? I don't know what the air temperature inside the balloon is, but I know that in the boiling water, it's greater than 23 degrees. So I'm just going to say T2 is greater than T1, or 23 degrees. So now I'm going to take this even bigger balloon and put it in the cold water. So we can see that the balloon is cooling off. It's in the cold water, and you see it went back down into the beaker, and it's quite a bit smaller now. I'm going to let it get colder. Okay, and our new circumference is I'm going to get a little colder. Oh, sorry. It's a disturbance. It has to happen. We're in school. The new circumference now is 27.8 centimeters. So, when the temperature, this temperature is less than 23 degrees, this circumference is less than 28.4 centimeters, which was the circumference at 23 degrees. Okay, so once again, as we increase the temperature, the volume increases. As we decrease the temperature, the volume decreases. We can calculate, if we need to know what the air temperature is, we can calculate that by finding the volume, which we're not going to do, just right now wanting to show you about the behavior. Okay, and that's the end of video